Today we're going to be looking at the cosine rule. This is a rule that we can use in non-90 degree triangles to help us find either a missing side or a missing angle. Now when we name non-right angle triangles, we name the sides according to which angle they're opposite. So if this is angle A, then the one opposite would be side A. We use lowercase letters. The one opposite angle B is lowercase b, and the one opposite angle C is lowercase c. Now we tend to use the cosine rule if we have been given two lengths and the included angle, and we are asked to find the length of the third side. So say, for example, we knew the length of B and C, and we knew the size of angle A. We could then work out the length of side A. And the way this rule works is that A squared is equal to B squared plus C squared, take away 2 times B times C times cos of angle A. So that is the general format of the cosine rule, and this is what you will see on a formula sheet given to you in an assessment. So if the side that you are trying to calculate goes here, the other two sides are squared, it is these two sides that are in here multiplied together, and then the angle is the one opposite the side you're trying to figure out. And I can rewrite the letters depending on which side I've been asked to calculate. So for example, if instead of trying to find length A, if I instead wanted to find length B, then what I would do is I would change the order of the letters. So if I wanted to find side B, then I would write B squared over here, and then I would take the other two lengths and write their squares. And over here I would have AC, and then cos of the angle that's opposite the side, which would be cos B. In a similar vein, if I needed to find the length of side C, then I would write C squared, and I would take the other two lengths, which are A and B, and I would use those letters here, and then the angle opposite our unknown side. So all we need to do is, given the values on the diagram, we adapt the cos rule to suit us. So that's what we do if we are trying to find a missing length. The other way we are sometimes given this question is we are given the length of all three sides, and we are asked to find the size of the angle. So again, we would write the cosine rule depending on which angle we are trying to find. We would substitute our values and then rearrange to get it as the subject of the formula. And I will show you how to do that now. Let's look at some practical examples of where we use this. So here is an exam question. You are given a non-90 degree triangle, and you are asked to find the value of x, and x is one of the lengths of the triangle. Now, I cannot use the sine rule, because for the sine rule, to find a length, I would need two angles. I'd need an angle here opposite the 10, and then I could work this out. Or I'd need an angle opposite the 13 that I could pair with this. So I cannot use the sine rule to solve this question. So I'm going to use the cosine rule because I've been given the length of two sides and the included angle. And I've been asked to work out the third side. So the first thing I'm going to do is I'm going to name the corners of my triangle to make this easier for me to work out. It doesn't matter what letters you use, but because you've got A, B, and C on your formula sheet, it's probably better to stick with those letters. So if that's angle A, this is length A. This is angle B, this is length B, and that's angle C, so this is length C. So I want to use the cos rule in this format. I want C squared to be by itself. I want the other two letters and then I want cos of angle C. Now that I've established which letters I want where in my cos rule, I'm going to substitute those values in. So instead of a C, I'm solving for x. So I'm going to write x squared. Instead of A, I'm going to write 10 squared. Instead of B, I'm going to write 13 squared. And then this is 2 multiplied by 10 multiplied by 13 multiplied by cos of 100 degrees. And then I'm going to type that into my calculator. So I'm going to write 10 squared, add 13 squared, take away 2, multiplied by 10, multiplied by 13, multiplied by cos of 100. And then I press equals. And you'll notice that I haven't deleted anything on my screen because I mustn't round off. At this point, rounding off would be a mistake because I'm not finished the calculation. X squared is equal to this number and I want to find x. So I need to square root this answer. So I press square root, answer, and it gives me 17.724. Then I go back to my question. This is always a very key point. You always go back to the question and check how many decimal places you're supposed to answer to. This tells me 1 decimal place, so I'm going to look at the second decimal place. It is smaller than 5, which means I mustn't round. So I'm going to say x is equal to 17.7 centimeters. And that is how you find a missing length. Let's try a different question. Here we are asked to calculate the value of x. X in this question is the angle, and they have given us all 3 lengths of the triangle. So again, I can't use the sine rule to work this out, because for the sine rule, if I want angle x, I need at least one other angle to pair up the sides for the sine rule. So I'm going to have to use the cosine rule, and I'm going to name my triangle first so that I know how to write my cosine rule. And again, I'm going to choose A and B and C, and I'm going to say this is opposite angle A, this is length A, this is opposite angle B, this is length B, opposite angle C would be length C. So now I need to think, I want cosine of angle B because I need to find out how big angle B is. So that means I need to have this side as though I was calculating this side. So I'm going to write B squared is equal to Now I use the other two lengths, a squared plus c squared. Take away 2 multiplied by a multiplied by c multiplied by cosine of angle B. So now I've got those in the correct order. Now I can substitute my values. Now I know what B is, so I'm going to write 20 squared. A is 16, so 16 squared. C is 15, so 15 squared. Take away 2 multiplied by 16 multiplied by 15 multiplied by cosine of angle B. And then I can use my calculator again to work out our missing values. Okay, so 20 squared, we've got 400. Now I'm going to work those two out and add them together. That's 481. And 2 multiplied by 16 multiplied by 15 is 480 times cosine of angle B. Now, I want to solve for angle B, which means I need to get cosine B to be by itself on one side of the equal sign. So what I want to do is I want to take away this 481 here. But if I take it away from there, I have to take it away from there. So what I'm left with is negative 81 is equal to negative 480 cosine angle B. Now, what I've got here is I've got cosine B multiplied by a number. So to get it by itself, I need to divide by this number instead of multiply by this number. So I'm going to divide both sides of my equation by negative 480 because the cosine is being multiplied by negative 480. And what that's going to do is it's going to leave me with cosine angle B. And then I'm going to end up with a positive value over there because a negative divided by a negative is positive. You'll see when I do the actual division. And at this point, you can leave it as a fraction. And the reason I'm going to do that is because it allows me to avoid having to round off. Or you can use your calculator and you can show the decimal value. At this point, it doesn't matter because what we're going to do, if you remember, cosine is the ratio of the adjacent side to the hypotenuse. So it's fine to leave it as a fraction. But we don't want to know what cosine B's value is. We want to know the size of angle B. So when you want to find the size of an angle, you use shift before you press cosine. So we want to press shift cosine, and then we want to use our answer, which our calculator has kept very nicely for us, and we press equals. Now, that means that angle B is the size. But the question now we can round off, but we need to know exactly how to round off. So before you write it down, you go back to your question and it says, give your answer to 3 significant figures. Now, not 3 decimal places, 3 significant figures. So 8 is the first significant figure, then 0, then 2. So I need to look at the 4th significant figure. It's larger than 5, which means I need to round up. So this is going to be 80.3 degrees. Now that's my x. So my final step will be to say that x is equal to 80.3 degrees. When I did the substitution here, I could have replaced it and put the x in there as well if I had preferred. It makes no difference to your final answer. So those are the 2 basics. You're given 2 sides and an included angle, and you're asked to find the 3rd side. or you're given 3 sides and asked to find one of the angles. We can switch it up a little bit and give you a question like this, which asks you to find the value of x over here. Now, to strategize this question, start by looking at where x is. X is by itself in a 90-degree triangle. If you have a 90-degree triangle, you have 2 options for finding missing lengths and angles. You could, if it's a missing length, you could use Pythagoras. We are not finding a missing length, so Pythagoras isn't going to help us much, but we asked to find a missing angle in a 90-degree triangle. So what we would want to use in our 90-degree triangle is we would want to use our standard trig ratios. So in our 90-degree triangle, we could use either sine of x or cosine of x or tangent of x. But in order to do that, we need 2 lengths in the 90-degree triangle. And we only have 1 length. We have the adjacent length, because this would be the hypotenuse. This would be the adjacent length to the x, and this would be the opposite length. So we want one of these lengths, because then we can use one of these ratios to find x. But at the moment, we don't know either of those 2. So now we're going to move into the other triangle that we were shown. And now we're going to look and see what we can do in this other triangle that might help us to use one of our ratios. So now we want to cover this triangle. This triangle then is a non-90-degree triangle. So we can't use any of these, but we could either use the cosine or the sine rule. So let's give this some letters. Again, make up your own letters, put them on the diagram. If we're still ignoring this part of the diagram, this would be length C, this would be length B, and this would be length A. Now, I want to find this opposite. Because it's opposite in the blue triangle, it's length A in the red triangle. So what I want to do is I want to decide which rule to use here, sine or cosine. Now I've been given 2 lengths and the included angle. So that tells me I should use the cosine rule. Because I want to find this length, but I've only got 1 angle. And if I want to use the sine rule to find a length, then I have to have 2 angles. And I don't have that in this diagram. So I'm going to use the cosine rule first, and I'm going to find this length. And in the red triangle, that length is called A. So I want to have A squared. Then I need the other 2 lengths. And the A angle. So if I use that, I will be able to work out this length. So I substitute my values. B is 13 centimeters, C is 10 centimeters. Again, I use the 13 and the 10, and A is 40 degrees. So I'm going to bring out my trusted calculator. And I don't round off because I need to square root. So I square root my answer and I get this. Now again, I'm going to have to use this number. I'm going to have to use this value in another calculation. So I don't want to round this off. I don't want to lose the value here. So I can round it off here if I want to. I'll leave it at 3 decimal places, but I'm not going to erase it from my calculator. In fact, I'm going to store it in my calculator so I can use it again later. So on a standard Casio, the way I would store this number is I would go Shift, Store, Memory, because now it's in the memory of my calculator and I can recall it, because the calculator has rounded it off to the number of places it can fit, but it's still stored the value properly in its memory. So now that I found the value of A, I can now use it to find the value of X, because now I know that this value here is 8 point all of those numbers. So now I need to choose which ratio I need to use, sine, cosine, or tangent. And to help me with that, hopefully you will remember this mnemonic. SOHCAHTOA. I have been told the adjacent value. I have discovered the opposite value. I know nothing about the hypotenuse. So I want the ratio that has opposite and adjacent. So I want tangent. So I'm going to say that the tangent of X is equal to the opposite value divided by the adjacent value. And then on my calculator, that's all I need. I'm finding an angle, so I'm going to press Shift Tan, and then I'm going to press my fraction button. I'm going to recall the memory where I saved my number, my previous answer, divided by 5, close the bracket, and then I press equal. So now I know the value of X. My question says, give your answer to 1 decimal place. I look at the second decimal place, therefore it's less than 0, so I don't round up. So this is 59.1.